Okay, folks, do some binary decimal hexadecimal conversions. And what we are going to do with this is I'm going to show you where hex and decimal and binary and all this stuff shows up in the world of computing. Also, we'll do some basic translations between these decimal numbers, binary and hex, and between binary, decimal, and hex. And this is a quiz that will be posted in Canvas, but I want to get through this little bit of a video here first. First of all, I want you to just take a second and think about everything's ones and zeros in the world of computing. I mean, everything, software, hardware, everything is ones and zeros. And let's take a look at some of them that you're familiar with. Is the colors on the web. So notice the hexadecimal number right here. There's the hex number, and then I can change the colors all the way down here to red. And notice my hexadecimal is changing. Okay, so we see hexadecimal all over on the web when it comes to colors and displaying individual characters. And when we talk about converting pictures and sound, all this is converted to ones and zeros. So basically, here's a quick picture of what actually happens when you have a sound wave that is actually coming through, and every few milliseconds you find out what this value is in ones and zeros, and then you translate that into ones and zeros. Then you translate the strength of the sine wave into your ones and zeros, and then this is what you actually get. So if you listen to an MP3, there's actually a difference between an MP3 and the actual file that's recorded in analog on a CD, a dot wave file. A dot wave file, analog, that's why it's so much bigger. When you convert it to MP3, it's so much smaller. Well, there's a loss in the sound wave. Now, some people say they can hear the difference. I can't. But nevertheless, this is there's many places where this shows up. It shows up in networking, and I'll go over to here, open a terminal window, and I'll go IPA here, and I want you to look at this noisy screen. This is my Ethernet adapter, and this is the current IP address of my Ethernet adapter, and it's 10.0.0.10. I have another one in here, another Ethernet, and it's 192.168.0.115. So this other Ethernet is my wireless, and it's connected to one machine, and my 10 dots connected to another. So these are actually binary numbers that are moving up and down the Ethernet. Here is an example. This is my MAC address, the actual serial number, if you want to call it, of my Ethernet card. This is stored in any physical device that's connected to the internet, and this is how the NSA finds you and the bad guys. So this stuff is around, and it's connected to everything. Okay, and let me go over here, and even things stored on disk. Here's a simple file, and I've called it hi.txt, and is not much in there. So if I edit it with my editor, and I'm using Linux for everything here, and what I'm going to do now is convert this into hexadecimal. I want you to notice that there's my hello, and notice hello is 6.8 in hexadecimal, and 6.5 is E. And notice I stuttered here on world. And what happens is you kind of have to count backwards. So here's the 1, and this little dot is my carriage return. So here's 31. Here's my little dot where the carriage return in. Notice this is a space. Spaces are hexadecimal 20. You've probably seen that encoded in your URLs, okay? And then we go back, and I'll show you that in a second. And let's look at Notice here we have it. Hello world, lowercase w is 57, uppercase W is 77. How do I know that's a W? Well, it comes right after the space right there. The space is right here. And if I look at my numbers, notice I have 32 in hex, 33 in hex, 34 in hex, and notice it's 2, 3, and 4. So when you look at hexadecimal and you see a hexadecimal 33, it's a decimal 3. So you see this as a carriage return, and you're going, I don't get all this. I don't know why I need to know this. Well, it shows up everywhere. It shows up in your programming codes. It shows up on storing on disk. It shows it's stored everywhere. So now I can actually take that file and cat high.txt into the screen and run it through another tool called hexdump, and I think it's uppercase C, and there it is. That's what's stored on disk. But what's really on disk is ones and zeros, and that leads us to this next section where we convert decimals. Notice I've got 172 here. Notice I got 192. Notice I got 168. These are probably some of the IP addresses that you have in your house. So if you open your command line on Windows and type in ipconfig, you're going to see your IP address. Well, that IP address is represented in decimal, and actually on disk it is 8 bits. Now each bit is a 1 or a 0. So we have 8 bits making a byte and 4 bits making a nibble. Okay? And this is what happens, is that we represent hexadecimal and binary kind of interchangeably in the world of Linux and Windows and Mac and Ethernet and cloud computing. So basically we store it in hexadecimal when it's actually a bunch of binary ones and zeros. So how do we do this? It's pretty simple. To take a decimal number and convert it into binary, we simply add the values of what we've got here. All right? So if we were to add 128, 32, 8, and 4 together, we would have all the same. It would add up to 172. So this is the pattern I want you to remember, and it goes 1, 2, 4, 8, 6, 16, 32, 64, 128. And if I added another bit, guess what it would be? Yep, 256, 512, 1024, just like the memory segments on your PC. So let's take a look at one here, and I want to convert 42 into this binary. So what I'm doing is I need to look at these numbers. Well, if it's 42, I can't use 128, can I? It's too big. Can't use 64, that's too big. So I can use a 1. I can say 1, okay, 32. Well, 32 and 16 is too big, so put a 0 here. And then 8, well, that gives me 40. Whoops. There's my 40, and I don't need a 4. I only need a 2. There's my 42. I'm typing in the wrong things. And I put in 0. Okay? So for the sake of what you will be doing to create the answer for 42, I will want you to write 0, 0. Use leading zeros, because the quizzes are pretty brain dead. They don't understand that. And then to take these binary numbers and convert them into hex, we just use these 4-digit pattern here. We go 1248, 1248. But in hexadecimal, it's actually base 16. Binary is base 2. So when I have a binary number, I type in 1 and then 0. Well, now I need to add a carry, And now I have 1 0, and then 1 1, and then 1 0 0. And you can see where these patterns line up. That's how binary works. It's only ones and zeros, and there's no digit bigger than 1. In hexadecimal, it's base 16, so what happens is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, just like you would think, except it's base 16. So we can't write a 10, but we can write an A. And then if we look at our pattern here, 0, 2, 0, 8, just like up here, 0, 2, 0, 8 equals 10. 10 in hexadecimal is actually A. So I can use a little notepad here and say 10 and, or let's just do it this way, make it easy. 10, 11, 12, 13, 14, 15. You don't write those numbers in. You can't write 15 right there. It would break. All your computing would die. In hexadecimal, you have to use your 4 nibbles, and there's 0 through A. And with the 0 through A, you can spell some fun things, like you've probably heard in the news that they use this code dead beef in hexadecimal to break down the centrifuges in Iran. And then there's other ways to spell things, like you can spell C 0 FFEE, spell coffee, or decaf bad. So you can spell a few letters and have some fun things using hexadecimal. But this is just to let you know that you do not use number 15 or number 14 when you are counting this. So this in binary is the letter E. Okay? So I'm going to take these back out because I don't want to confuse you. All right, so we just use that for a mnemonic. So when we count binary and we say, well, A plus 4 is 12, oh, I can't write 12, but I can write a C. That's how you know to convert. And that, in essence, is what we'll be doing in the quiz. And I will be uploading a couple PDFs for you that you will have to. This is a worksheet to kind of help you play with it. This is the binary hex pattern. This is what comes off the computer, at least on a Linux box, to tell you the different hexadecimal codes. Here's some charts. And so if you practice, okay, how do I convert 192 into a binary number? And then I take that binary number and convert it into hex. That's it. And then I'll give you a blank one where if you go through and fill out all the blanks, that's what the quiz is. The quiz is just you fill in the blanks from the worksheet and you dump in the numbers. So that is a very quick overview of how to get binary decimal, hexadecimal conversion. You will see this everywhere in computing, discrete structures, assembly, you will see it in networking, everywhere. So on that note, thank you for your time.